another thing to just understand and accept as an engineer is no one cares about work time. It's like calendar time. Like everyone else is going to translate it to calendar time, so you better do it for them.
Lou, you wrote a book, Swimming in Tech Debt. The problem with tech debt, though, is nobody knows what it means anymore. So what is tech debt?
Sure. So I think probably we're all in the same general area of what we think it is. We don't maybe not agree. So what I've tried to do is not necessarily like say this is the definition and you should use it. It's more about trying to find a definition that's a useful definition, that you could use the definition. So for example, I do not feel that the widespread financial debt metaphor of tech debt is useful because it doesn't tell you what to do about it. I think it causes problems in the way people, their mindset around it. If you think of it like debt, a real debt, you have an obligation to pay it, usually a contract. It would be fraud not to pay it, which is not true for technical debt. I think there's a lot of things that I would classify as technical debt that I don't think you should do anything about. And the other thing is this idea that it came from this shortcut that you took, and that was a bad thing that you did, and now you owe this debt back because of this intentional thing that you did, and you knew you were going to have to do it, take care of it later. Where I don't think of tech debt as like that at all. I think a lot of it just happens because the world changes. If you have a code base that's long lived, frameworks change, languages change, technologies change, and they can render code base into debt without you having done anything that anyone would consider a bad engineering practice. So what I like to do is I think of it as swimming upstream. That's the metaphor that the book title is trying to give you, and the one that I think is more useful. And it's useful in two ways. One, when you're in a code base and it's got a lot of technical debt, you're kind of surrounded by this resistance that's stopping you from making progress on where you're trying to go. So you have a roadmap that you have to implement, and the code base is resisting you from doing that, causing mostly developer productivity problems. And it's an internal to you. And the second thing that you get with this metaphor is that anyone outside of the code base, anyone who's not spending time in the code base, kind of doesn't understand it. And when they look at you, they just see you as being slow. And they don't, and no matter how you try to explain it, if you're not in the water, if you're not feeling the resistance, you're not totally going to get it. So using that definition, I have gone in lots of different directions in the book to kind of like give you ways to use that, to find the tech debt, to deal with it, and to find strategies for explaining it to the rest of the business, to your managers, and so forth.
That's interesting. So there's a couple of things I want to pick apart there, because I do like the financial metaphor as a way of communicating to senior managers that we have incurred some cost, if you like, we've borrowed against the future, and we either have to pay that back or we carry a debt into the future. And I'd argue that some business debts you can indefinitely never pay off. You can just keep paying interest forever.
Yeah.
And eventually, if you don't pay that debt off and the interest keeps accruing, you build up the interest, you will go bankrupt. So from a way of communicating it, I think it has some merits. I think it's perhaps abused. I think what's really interestingly pointed out there, though, is that actually we seem to, I was thinking as you're talking that we've kind of conflated two things when we talk about it. We've talked about that metaphor, which is really supposed to be a way of communicating to senior managers that we have this cost of doing business. And we've conflated it with actually what we want to describe to each other and what we want to talk about more perhaps within engineering is we have this friction. We have this thing that's holding us back when we're trying to swim upstream. And again, that might not be deliberate choices. As you say, it might be that technology's aged. It might be things have changed. The world's moved around us. Let's take that financial thing again. If you're dealing in finance, regulations have changed. So now we've got to do something. So maybe there's a need for us to have a way of communicating it.
Right. I think, again, if the definition is working for you, don't change it. But this is where I would say I have my problem with it. If you accept that it's you have a principal that you owe back, and that you have an interest rate that you owe back, and that you have some financial thing, the next question to ask by the business is, what is it? What is the number? you know, and that is extremely hard to come up with. I don't think anyone has a methodology for saying, oh, well, our principal would be, 150K. And if we don't pay it back, we owe, a 2% per month. I mean, I don't think you could justify those numbers. Again, if there's some way you can turn it into money and you feel like very strongly that that is correct, then maybe you'll find a way to use that in a way that the business can actually use. But the more you try to turn it into something like what they have already, then the more they're going to run with that metaphor. Like if a metaphor is correct, then they'll try to apply all the things that they normally apply to that metaphor, which is going to come down to, you're going to have to declare an interest rate or something. And I honestly have no idea how to do that for a large project. I will tell you that I've tried to come up with a methodology to kind of, in a way, size what I think it has to do with how to size technical debt. And part of that, I'm going to say that part of that, and we'll talk about that later with the 8 questions, is thinking of a order of magnitude of the interest payment and frequency is part of it. But then there are like 6 other things that I also go along with that because I think it's more complicated than just an interest payment. But again, if that is working for you to get tech debt paid, obviously I think you should continue to use it. And maybe think about the kinds of things I'm saying as another tactic to use when it's not working.
Sure. I think you're very much on point with trying to explain the principle is quite difficult. For the kind of interest, what it costs us each month, I think perhaps that's a little bit easier and where it's more useful as a metaphor, in that we can go back and say, every time we do this, we have to spend 2 days or 2 weeks or 20% of our time dealing with this friction. This is what this friction costs us, or we double all of our estimates, or however you want to.
Yes.
You'll have some measure of that incentive.
I do agree with that. And like I said, I do include that in my 8 questions. 2 of them deal with that, because I do think that is possible to some extent. I just think you need. I'm trying to be more expansive about all the other costs and benefits that could go along with it, including the costs that come with doing something about it. Not just the work, but more costs than that.
Okay, cool. Let's get into those 8 questions in a minute then.
Yeah.
Let's circle back to kind of what is technical debt. So we've talked about some deliberate choices you make, and we've included the frictions, the things that are holding you back that could come from, as we say, the world changing, so on. What would you exclude from that?
Right. So like a lot of things, it's a continuum, right? There's a lot of gray area. And, this kind of thing comes up with like, is it a bug or a feature, right? like what kinds of things? So there are just generally things I think if it has more of these kinds of things, then I'm going to think of it more like tech debt. So the more that it's an internal problem that is mostly having developer productivity effects, the more it has that, the more I'm going to think of it like tech debt. So for example, something like messy code, like hard to read code, bad variable names, or very long functions, or no tests, those things are all internal effects. If you fix them, it doesn't necessarily change the software at all. No one would even know that you did it. Like those kinds of things are going to fall in my tech debt bucket. But also if you have a target architecture, that's your idealized architecture, and by not having it, it's harder to implement some of the parts of your program, and that's internal effects. I'm going to think it's more like tech debt. Now, lots of times there are also associated external effects. So, for example, security effects or performance effects, or like you can't scale things, and that doesn't necessarily make it not tech debt if the tech debt is the reason for that. But if it's only that, right? Like if it's only the visible effects, it's only performance effects, the code is totally perfectly fine and easy to deal with, but it's not performant. Well, if the performance is causing a problem for your customers, then obviously your product manager cares about that, and they would, if they don't, then you probably shouldn't deal with it. But if they do, it's just a normal roadmap thing, not a technical debt thing. That's just an external effect. So if it only has the external effects to the customer, and that's the reason you're doing it, then I would less classify it as tech debt. The more it has the internal effects, the more I would classify it as tech debt.
So almost says that performances doesn't meet specification or doesn't meet
Yeah, if it's
what we
something that your
require of
customer
it.
cares about, then and not just that you think they should care about it. Of course, it would be better but they would pay for more performance. Then that would be like, or it's stopping them from upgrading or renewing. But these are things that would be on the product manager's radar. The more the product manager would be able to understand the specification and care about the thing that we're talking about, the less I'm going to think of it like tech debt, because I think of it mostly as an internal, like I say, water that you're swimming in effect. And a lot of things are both, right? Like, and then there are a lot of things where like you have a choice. Like we could get this performance by doing, again, maybe we'll call it borrowing, right? Like we could do something that's not dealing with the internal. Well, then that thing would be more of a, you're not dealing with the tech debt. But if you're going to try to do both at the same time, then I would more classify that as tech debt and more put the engineers in control of that specification of what's going to happen, which is one of the things one way to think about is who's caring about the specification the most. When you have developer tooling, when you're doing your internal build maintenance, when you're doing your CI stuff, when you're fixing these technical debt problems, naming issues, language change issues, framework, like the developer is deciding the specification. The more that's happening, the more I'm going to think of it like tech.
I think that's a really useful split. I saw some comments today on one of the social networks with somebody saying it's technical debt if it's in a language I don't know.
Yeah.
What's your thoughts on that?
I mean, if you go by the definition of resistance, to that person it would be, right? Like, so because it would be slowing them down. And maybe it is true that technical debt is a personal thing. I have definitely been in code bases where I was at the company for 5 years, and a lot of code that was frankly, maybe I wrote it. Like, I understood it better and I could operate in it better, and it did cause problems for other people. So I definitely see the argument that it could be personal. There is a definition I often hear of legacy code. Legacy code is code I didn't write. So like it kind of goes in that same bucket. So I see the argument. I tend to think of technical debt, larger technical debt, as being a team responsibility. So if the team feels that way, none of them know the language, because maybe we're in a code base that's changing from one to another. Then maybe we would classify those things as technical debt because they're causing on a team level some resistance.
Yeah, I think that's a crucial aspect, isn't it? It's got to be on a team level.
Yeah,
not just an individual doesn't like it, doesn't know it.
Definitely not. Stack. A big thing I talk about it in the book as an enabling practice is a guide, a more than just a style guide that's like about indentation and braces, but more about this kind of thing. What languages are the ones that we accept into the code base and for new code, even though there might be old code that doesn't do that. But if the team decides together on an agreement of a certain way things are going to be, well, then anything that's not that, I would classify as bringing in debt into the code base.
So we've defined technical debt for the purposes of this conversation, what we're meaning by it in this, which I really like, as that things that are causing friction to the team. I think it's fairly obvious from there, to my question of why should software engineers care? Because we don't want friction in our day-to-day lives.
Yeah.
What about the managers? Why should they care?
And just to say a little bit more about the developers, like we're the ones mostly feeling it, so that's clear to why they should. But there's an aspect of frustration and depression and anxiety that you for self-care reasons you should not want to just always be fighting against the code base. And I know that when I say this to engineers, they totally know what I'm talking about. And then where it kind of manifests itself is, I think the most is that you estimate and you give somebody a public estimate of how long you think something's going to take, the work time. And what tech debt does is spread that far away from calendar time, which is the only thing other people care about. And that spread causes you to have anxiety. And it is much more likely to happen when you're dealing with code bases that are hard to change. because you didn't take that into account when you gave that estimate. And now you have to sheepishly go back and explain like something that's like a thing you can't even explain. And that maybe you feel is kind of your fault, right? Like, because you're like, what is this? I didn't tell you to make the code base hard to change, right? Like, so I think for the purposes of self-care and depression and frustration, anxiety, like you should care about it more than just the technical reasons. And you were asking about managers. How do we make managers care? Well,
so yeah, but just before we get into that question,
oh, sure.
I think there's an interesting thing there, in that I've always thought that we need to quantify technical debt to communicate it to managers and executives, but maybe we also need to think more about quantifying it for ourselves, so that we start getting that difference between calendar time and work time factored in far more. So another factor on top of take an estimate and double it.
Yeah. Yes. So, but managers, so, you're going to have a wide degree of what your managers might understand about your code tech debt. Like, so I've worked in startups where my manager was writing code right along with us. They totally understood everything about what was going on. And I've worked at places where, where the managers didn't do any work in the code base, and even like maybe what weren't even capable of understanding the code base, even though they might be technical, but this code base was not something they were familiar with. So, and then there's their managers. And when I worked at Atlassian. So, there was like 4 or 5, layers between me and the CTO. And obviously at every layer, it's going to get different. So this is where I start to think about the visible effects. Like, so this is where you can kind of like get some support behind something, is thinking about the visible effects. Now, there might be visible effects to the customer, and if that's true, that's great. I think it's going to be easier. But there are also visible effects to the other departments, right? To support, to DevOps, to QA, to your product manager, to sales and marketing. Like they might see the issues. Demos seem not to work all the time, or we get a lot of support cases around this thing and we're trying to explain this thing, and even though the customers are kind of okay, like there are effects that are happening. There are also ways, and if you have those, that's great, and I think you should try to do that. But there are also ways to make internal things more visible. So to give an example, we had a problem I was on the iOS Trello iOS team at Atlassian. And our builds were very slow. So building an iOS app from scratch, I don't know, it took several minutes, and that causes you to have, delays in your work when you can understand. Like a lot of people who work with like non-compiled languages, they're like, what? like I just saved it. But it could be bad, and even a partial build could take too long. And so one of my colleagues wrote a little script in our builds locally and in CI to collect that data, the build time data, and then showed it on a dashboard. And then we were able to use that with our manager's manager to get some support back towards, well, the first thing they did was they sent us new machines, which was great, and that did help. But even that wasn't enough, and we were to get some support to investigate it, and we found out that what was causing the problem was the compiling interaction between Objective-C and Swift as we were trying to move from Objective-C to Swift. And this allowed us to justify spending a little more time converting more Objective-C to Swift, where if it was if areas were entirely Swift and not importing in Objective-C, then they compiled faster. So so that we were able to show some visible effect, and we were able to show that build time coming down, and we were also able to show the code base, the amount of the code base that was being modernized. And that was enough to convince our manager's manager to support our manager in supporting us doing that work. And there are things that you could do like that. And I have a lot of examples in the book of various visibility things that you could do to make internal things more understandable by other people. And I think that helps.
That's a great example. And I've had a similar experience. I joined a startup a few years ago. Very small startup, not particularly fresh, British startup. So, third round of funding was about £1 million, not the big Silicon Valley levels. But again, in that, I saw developers who are building C++ projects. It was taking 45 minutes to compile. And they were doing that 2 or 3 times a day. And it was really simple just to say to people, get your pen, paper, put a little line every time you build, record the start time, record the end time, and just give me that at the end of the week. And I'm like, why? And it was like, well, I simply take all these numbers. I went to the CFO and went, "This is how many times we build. This is how many
Yeah.
times, how many minutes it takes on aggregate.
Yeah.
We are losing this many hours a week. What's the average salary that we're paying our developers now? Can I have £4,000 to go and buy like a bunch of new computers for them?" And we did that, and it brought the bill down to 2 or 3 minutes each. And
Oh
again,
yeah, that's huge.
but it's a very trivial example, but it was something
Mhm.
that nobody really thought of. How do we just
Right.
get some metrics? How do we go and
Right.
get that impact?
Yeah. As I'm kind of trying to explain that mostly is causing a developer productivity issue. If you can figure out how to quantify that, that's what mostly this tech that is causing. You could probably, if you keep that mindset of that's what it's causing, then you can find things like this. Well, how does it manifesting itself? It manifests itself in a couple of different ways. I'm going to say one way is just making things take longer, but there's another way that it does manifest itself, which is I'm going to call it lengthening feedback loops. So when you have code that is hard to understand, hard to change, hard to when I'm coding it, it also causes that problem in code review. And it causes it in two ways. One, it causes the I'm going to just call it an idle time problem, because people are just like dreading like looking at that code review, and it just kind of sits there a little longer. Again, that gets to the calendar time versus work time, but it's got it. Code that's easier to review honestly gets reviewed faster, sometimes almost right away. It's like, and then the review, like if they find problems, they kick it back, they don't understand it, there's not enough tests, how do I know this really works? Oh, maybe I need to run it myself. The review takes longer, I find more problems, I kick it back, you have to do it again. So you're just causing this like feedback cycles, that causes productivity problems. You should be measuring something with code reviews to understand that idle time, review time, number of times it goes back. That to me, that's the one where you're going to see the most. Honestly, I think that's where the biggest problems are, because they're really long. If it takes me an extra hour on top of a 3-hour project to understand some things, okay, that's something. But like, this is days on top of that, like in calendar time, right? Even though you might be making a productive use of the other time, like seeing the roadmap get burned down is just going to take longer. Even though, yeah, okay, the estimate of whatever it was truly how much time I worked on it, but who cares? Like, it was 6 weeks late. Like, I think honestly that another thing to just understand and accept as an engineer is no one cares about work time. It's like calendar time. Like thinking calendar. Everyone else is going to translate it to calendar time, so you better do it for them, and think about that and keep an eye on that. Feedback loops are the big reason that starts to stretch.
Yeah, on that note, I know it's very easy as software engineers for us to all hate on Jira and all hate on using it.
And as an Atlassian person, they all tell me as soon as they find out. I wasn't on Jira, but we did use it, of course.
There's a couple of teams I've worked with in bigger organizations where the organization has put in all the steps. So they've put in, it's in design, it's in code, it's in code review, it's in deployment. And I haven't always agreed with all those steps, but I have found it useful that when the team used that workflow and got them to log the hours worked on a ticket, to then be able to pull that information out of Jira and say, right, this ticket, we've logged 8 hours work on it, and it took 8 days to get through that process. Most of the time it's sat in idle. It went from code complete to code review in 4 days or something. You've got all those metrics then to start saying, well, where are our friction points? Where are the bottlenecks? Where are those things we can target? And it's odd. We talk so much about observability in building and deploying software to the web, but we hardly ever have it in our development processes.
Absolutely. That's a thing I strongly recommend in the book. And often it's a first step in solving these problems, which I go through several examples of it. The build observability was one example, but often when you don't have really a handle on what the problem is, a first step is put some metrics around it, because then you could start to get at what the true cost is, or at least something that correlates with the cost. If maybe you don't have a dollar figure, but you have a big enough effect that you imagine that it's valuable. And also the other thing it gives you is, if you have this, you also see the progress, which is motivating, and also lets you be able to explain it to other people. Like, we did this thing, and this this line went down. Like, and believe me, that's good for us. Like, hopefully, we did this thing that we set out to do.
It also gives you that focus, doesn't it? You can either target the low hanging fruit and show some easy, quick wins and get more buy-in, or you can say, well, actually, that's going to have a massive impact, and it's going to not cost too much to do. So we'll do that first and not have a huge impact. And again, as you say,
that proportionality is super important.
So if I circle back to why managers should care, if we accept that the manager's success is governed by the outcome of their team, the manager should care then as we're moving friction from the team, so we're going to produce more outcome or better.
You just have to give them some assurance that it's happening. Like it can't, like if they're not able to perceive it themselves because they're not able to understand the code base, you owe them, if you're the engineer and getting some autonomy to decide how to do things or giving some leeway, you do owe them something: accountability, visibility, observability, something back, so that they are assured that it is actually happening, and so that if they have to, they can explain it, to their management.
Okay, so let's talk about that at the next level, their management or the executives.
Mm-hmm.
What can we as software engineers give a manager to support that argument? How can we make it easier for them to go and argue the case for us if we're not in the room to make it?
Yeah. I'm going to say this first. Ideally, if you're an individual contributor, I'm going to just tell you this is how it worked on my team at Atlassian. And it worked really well. And I hope that people can adopt this mindset around it. I think that the engineering manager and team should be given some amount of budget without necessarily too many strings attached to it to deal with, I'm going to just call them the engineering specified work problems. Tech debt being one of them, dev tooling being another one, but just everything where like the developers are the ones who are getting the benefit of the work. The number that you choose, the percent of team or whatever, it kind of depends where your team is in the software adoption lifecycle. A true startup just starting, like, honestly, maybe they shouldn't have that much tech debt, or they're throwing away code, so they're not necessarily fixing it. They're not going to have as much. A team that's in a growth phase might be having problems caused by their code base that might have to deal with it. And then there's kind of like a leveling off phase or a stable phase or even a declining phase where there's just going to be different attitudes toward it. So you're going to have to think about that. Like, what's the right level? Don't make it zero. And then adjust it, keep an eye on it, adjust it. So that once you have established like this amount of budget is at your discretion, what you owe back to your management is that you are going to do some kind of objective, rational process to spend this money. Now, what I like to look at as a model is what product managers do. There are a lot of frameworks they use. A very popular one is RICE. The RICE framework. It's an acronym where they score anything that they would plan to do in the backlog. By looking at the reach, the impact, the cost, and the effort, and how certain they are, certainty and effort. It spells out RICE, and they use that as a way of understanding if a thing is worth doing. That's what I've tried to propose with the 8 questions, is also a scoring mechanism. I don't mean it to be like, oh, just add up all these numbers, and if the number is over 3, I don't mean it like that. It's meant to inform your intuition, meant to inform the discussion, and that you wouldn't go way off of what it's saying without good reason. Or if you were, you would use it as a guide to figure out how to navigate it. But you owe some objective process. It could be this, what I'm proposing, or something else. And then you owe, like I said, some sort of observability, some way of knowing that it's happening. And you owe them actual versus budget numbers, right? Like, so not just that you didn't go over, but also that you actually, if I give you a budget, I don't just want you to stay under it. I want you to spend, I am saying, I think our product needs whatever amount of time, effort, money to be spent on this. I want you to spend it, and I want the improvement that comes from it. And I want you to show it to me through these, dashboards, observability, ways of understanding it. And then I would always say, always look for those extra customer visible effects that are coupled to the thing you're doing, and like talk about that as well, because that's how you up the developer chain to the management chain to CTO. It's fine to talk about all this technical internal stuff. They're going to get it to some degree, but it's really hard to talk about that outside of it. No one cares about that much. You got to look for these like associated visible effects that come with that work and try to do it. A lot of times it's after the fact. Like for example, your reliability numbers might be going down after you've delivered. Keep track of like, okay, we did this work, we spent 3 months doing this work, and now for the next 6 months, watch this other external thing go down, crashes in the field, other things, failed deployments, the things that are that the whole business understands.
Yeah, I mean, there's two things I want to pick up on that. One, you mentioned earlier, like talking to adjacent teams, so like customer support might have some impact on that. Sales might just give you some feedback, so there's sort of that second order effects from it. So important, and something that so many developers forget is to talk to other people. Go and talk to the sales guys, talk to marketing, talk to the customer support, talk to the developer advocates or whatever you have in your organization, who are kind of that gateway to information from the customers and you. Build that network, build those relations so you get that feedback. And also, if, again, your observable effect might not be immediately visible to the customer, but it could be visible to those other teams, and they can champion you. They can help provide that information support. They can feed up with their management structures that this is helping. So look for them.
Yeah, and our team at our backlog grooming, a customer support person sat in and, weighed in on like what the support impact was. And often I would end the meeting like, okay, given all of these things, just for you, if I only cared about you and the support load, which would you pick of all of these things to be the most important? It was often not the one we picked. It was out of priority with what we thought. Now, it didn't necessarily win the day, but it definitely stuck in my mind. And sometimes I would find like a way to deal with it. To like, okay, like I'm waiting for this. I don't have time for that. I need something to do. Let me take a whack at that, like that problem. Let me just take a quick look. Maybe put some more logging or make a little bit of progress on it. Another thing to do is I'm going to say, if there's some problem, right? You give it some tag name in your system, maybe in Jira or whatever. Put that in the support cases as well and start to get a collection of support cases that are related to this thing that you think is a problem. And then you could track those over time as well.
Yeah, and that brings me on to the second point, that when we talk about people getting promoted and people getting new jobs, so many software developers say, well, I don't know the impact of my work. But again, if we're having these discussions with wider teams, with other people, it gives you that great ammunition, doesn't it, to say, well, actually, this work I did reduced churn by 4% or something. Now you've got that metric, now you've got that understanding, which helps you argue for paying down the technical debt, and it helps you with your promotions.
Absolutely. I mean, hopefully, I mean, I know this is not always the case. Hopefully your story that as specified by your product manager comes with some benefit hypothesis. That's the words they use in Safe Agile or Scrum or whatever. Even if it's not there, you should ask so that you could answer this question for yourself, even just for motivation. It's really good to know what you're doing for the business. And technical debt, like I said, it has more of this internal effect, more of a developer productivity effect. So you're going to be in that case. Like I said, the engineers are responsible for specification. They're also responsible for the acceptance criteria, the benefit hypothesis of these things. So now it's on you. You have to figure that out. And if you can't, maybe this isn't the thing that should be done. Use those techniques that product managers use to figure out if work should even be done, if a feature is even worth doing, if a bug is even worth fixing. Is this technical debt even worth addressing? It might be frustrating, but if you can't come up with some good reason to do it for your manager, you haven't gotten one for yourself either.
That's true.
Yeah.
And perhaps collaborate with your product manager on that, because if they show you and share their techniques, and you show them working through this example, you're going to get more of their buy-in, aren't you? You're going to have they'll understand that you've gone through a process. You're not just moaning about technical debt. You're thinking about it. You've got some evidence. You've got a hypothesis.
Because, I mean, honestly, and I don't think this is always the case, but there is somewhat of a feeling that sometimes developers might be choosing to do things because they want to try some new shiny thing, or there's this thing sometimes people say like CV driven development or whatever. Like it's not because those things happen all the time, but they do happen enough that there is some truth to it, and so you don't want to fall into those. Buckets. Obviously you wouldn't want to do that. I hope you wouldn't, but you don't want to do things that seem like like that, that it's just an opinion or just like using objective criteria that can be argued with your team and that the team agrees on the objective criteria is much better than, I hate whatever this, I hate this architectural pattern, or I hate whatever this tool and I just want to get rid of it. And I can't explain why, but whatever. Yeah, it's not a good way of getting it done.
Yeah, it definitely happens, doesn't it? That CV resume driven development.
Yeah.
And also the other things where we don't think rigorously enough, and we just say, well, I know this tech stack would be so much better for this problem. We should just rewrite it in that. And it might be well intentioned, but without that rigor and without thinking about it, it might not be the right choice.
Yeah, I think there's some room for subjective thinking. I do include that a little bit, but because of this depression, frustration, anxiety, like I feel like it's telling you something. There's a gut that's telling you something. I don't want to totally ignore it, but that's just like one of the factors. I don't even include it in the 8. I do as a bonus 9th factor, and I look at it with and without that. To make sure it's not having too much of an effect. But it's definitely something. Like, cool. I wouldn't ignore it completely.
So we've skirted around the 8 a few times.
Yeah.
Time to address it head on. What are the 8 questions that we should be asking about tech debt?
Okay, so I'm going to go through this fairly quickly so people will get bored by it. But the framework to be thinking about is that there are costs and benefits to doing something and costs and benefits to just leaving it alone. Okay, all right. And what we're going to try to do is we're going to call the costs and benefits to do something the pay forces. This is the forces that cause us to pay, and there are 4 of them. And then there are costs and benefits to not doing anything. And I call that, just for the rhyming aspect, the stay forces. Okay, so we have the pay forces telling us pay the debt, the stay forces telling us not to, and there's 4 of each. Broken into costs and benefits and so forth. I have a diagram, and it's a way of remembering it. Okay, so what are the benefits of paying? So the first one I want to talk about is, we've talked about a lot, is these external visibility effects. The more it has of that, it's going to be easier to show that to the business that this is a good thing. It's going to be more understood, more appreciated. And then the way I score it is like, how much is that rating? All the way to the customer would be getting big scores. To support, marketing, sales, like that's okay, that's good. Slightly less. If it's only to like engineering managers, QA, the really closely associated teams, QA, then that would be a less of a score. And if it's none, it's 0, right? So that's the first one. And that's the only one where I kind of talk about like these external business effects. The other 7 are way more about internal things. But I do want to have a one with that. The second benefit is this, I'm going to call it misalignment, where your code is not aligned to your accepted engineering practices, values, target architecture, and so forth. It should be documented and agreed upon. The more that stuff is agreed upon and documented, the higher the score you're going to get for the code being out of alignment. And this can happen because you've adopted a new framework or changing your language, or the code, you didn't used to have high test coverage, but now you have a higher test coverage. Like that's part of that alignment. You're not meeting your test coverage metrics or any other, static code analysis metrics or anything, any kind of metric that you might be putting on your system to tell you about your code health. And there are lots of commercial and open source tools to kind of give you an idea of what that is. That bringing your code into alignment is a benefit of paying that debt. So those are the 2 benefits. And then on the cost side of paying is this interest payment stuff, right? So I call it volatility and resistance. Volatility is how often are we having to be in this code? Like how much is this code changing? Not because of what we plan to do with it with tech debt, but just because of the roadmap and bugs. We're finding critical bugs in it all the time, where the roadmap is sticking us in this code all the time. And not just the past, which you can get by you can find out the past volatility by analyzing your repo statistics, and there are tools that will do that for you. And I think should look at those. But there's also, you want to look at short-term future volatility. So looking at the roadmap, where is it going to cause problems, and then the resistance is how bad is it, right? To deal with. And then it could be that you're dealing with code a lot, but it's easy to change. Well, that wouldn't be a big deal. Or the code is really hard to change, but it works fine. There are no bugs and there's no roadmap to fix it. Well, then that's also kind of fine. It's the combination of the two that's not fine, right? So, and that gets into, if I were going to put it in the financial metaphor, I would call volatility the frequency of the interest payment, and resistance the size of the interest payment. And that's where I put that element of the financial. All of those things together, if you have high costs to not paying and high benefits to paying, that's going to make the pay force strong, towards the pay. But against that is the stay force. And there are 4 of those. 2 of the benefits to not paying it. One is that this risk and chance of regressions caused by doing this work. So regressions, in case people don't know, I'll define that as a new bug in working code that people depend on. So like, you have a lot of customers depending on something working the way it does, and it's fine for them and they're happy with it. And then because of your tech debt work, you do a rewrite or something, you're mucking around in there, you cause a new bug in something that was working. So if you didn't do anything, that would be a benefit of not doing something. So your regression number kind of depends on like, how much is this code currently dependent on, and how bad would it be if it got broken, and how likely is that to happen based on what you're going to do. And you can find that out with observability. Your analytics will kind of tell you some idea of that. Another benefit to not doing anything is when you're just not even sure of what you're going to do is going to even work, or it's going to even be better. And I mean that from a developer productivity standpoint. Like, if you're going to be doing all this work to change something, like, how sure are you that it's even better? Like, we have this experimental new architecture pattern. It's it's one of those ones with the 5-letter acronyms and whatever, and that's better than MVVM because of something or whatever. It's the hexagon pattern. Like, is that even better? Like, is that like, you might not know that for sure. Some things are known for sure. Like, it probably is always better to have more unit tests covering your code, if they're not brittle. So that'd be a lower uncertainty score. And if you don't even know what you're going to do, I would definitely score that high. You have uncertainty. And then there's also costs to paying that are a force to not doing anything, which gets into your estimate. So the size, how much work there is to do. And I break it down into two things to think about. One is the idealized amount of work to do. So just like your best guess of everything goes right, basically how big is this thing? And then another number, which I call difficulty, which is the risk that number is not right. So it's kind of giving you a sense of like the mean and the standard deviation of your estimate. If you could get way deep on estimates, and of course you should do that when you're actually going to do the work, but this is a planning mode. We're not even sure we're going to do this yet. We're just trying to get like a finger, in the sand, like some kind of idea of the range that this is in. Is this a months long project or a days long project? Like t-shirt sized, and like how sure are we that number is right? So those are the 8 kind of spread in this cost benefit. And then what I do is I just do simple math, simple adding. I tried lots and lots of other ways of doing it, and honestly, it doesn't come out that different. And so I think the simple math is the easiest way to do it. Just net it all against each other, normalize it back to 0 to 5. And then see where you are. So in this case, we allow it to go negative, I should say -5 to +5. Normalize. 0 is like, it's kind of neutral. 5 would be, yes, there's a lot of indication that this should be paid. -5, there's a lot of indication that it shouldn't be paid. Now, I don't think, sometimes, even with a strong stay force, it doesn't matter. You still have to do it. Your growth is causing performance problems, and this tech debt has to be paid to get that visible effect. So then what I recommend you do is start with reducing those stay forces by doing things that reduce uncertainty. So come up with a good plan, do spikes, get some data on what's going on, reduce the chance of regressions by putting in good automated testing, putting in testing in, prepare to run two systems in parallel, and to do like slow deployments out to so that's getting at two of those stay costs. Maybe trying to do a little bit over time, like to the effect, so the effect of the size isn't so horrible at the beginning. Like if you have time to do things, like maybe break it up into phases, and then each phase might be easy to justify, and then maybe you'd have to stop, but you could still get somewhere along the way. And then there's also ways to increase the pay forces. Like, can you find visible effects that are going to go along with it? Can you make a team agreement that like now makes this code misaligned to that agreement? So that's how I would try to deal with something where the scores are kind of telling you that it's a very dangerous project. Is like, just try to use those scores as a guide of how to tackle this project. So I hope that overview gives you some idea. Like if you sign up to my email list, I go into each of these with some diagrams and some charts that help you visualize it. And then the book has even more details about it.
Yeah, I think that sounds like a great approach, because far too many of us as software engineers, we moan about it. We say somebody should do something about it.
Yeah.
But we don't take that structured approach. If our product manager came along and said, somebody should do something to get more customers, we'd be like, well, what features?
Yeah.
Go away and produce a roadmap. So
yeah,
we should do the same with ourselves. And I think that's a great way of thinking about it, and trying to, as you say, do the spikes, get the numbers, get the estimates, put together something concrete and be able to justify it. I think that's really useful. And I encourage everyone to go and sign up for your mailing list, see the pictures, and go and check out the book.
Thank you.
Awesome, Lou. So thank you for explaining the 8. So there's been a lot of talk about AI recently. Do you see that being something that can contribute to resolving technical debt, or something that might cause more technical debt?
Yeah. So I'm going to tell you my perspective for me. Okay. And so I am, someone who can read code. I've been coding, professionally for over 30 years, very comfortable with code. And I use AI. Almost everything I write, I'm writing inside of Cursor, and I'm either using the completions, or I'm chatting, or I'm doing all the features of Cursor, and other AI tools. And I am totally in charge of the amount of tech debt that's in my code base. Now, as I have always been. And has tech debt entered my code base under my direction? Yeah, yes. All right, like it has, and it still might. Right? But that was my choice. I review every line of code. I fix things. I rewrite them. I extract out common code if I see repeated code. I fix bad names. I do all of that either with more prompting, but usually just by, it's easier to fix it usually than to do more prompting. But I make sure there are unit tests, and AI is helping me do that. I can generate unit tests very easily with AI, and so. In the way I do it, I do my AI prompting at the commit size level, so one commit at a time, and I'm trying to build a commit history that makes sense to me. I'm not putting in like giant one shot, 10 new files, thousands. I'm not doing it that way. That's how I do it. If you don't do it that way, then I do think you are possibly introducing, I'm going to call it messy code kind of tech debt. And possibly architecturally, if it's not following your architectural patterns, hopefully you are making sure that it does that. But the more you're not reading it, the more there's going to be little problems in it that you might run into. And then at the other end of the spectrum, let's say a vibe coder. So, and by that I mean someone who does not read the code at all. Whether they could or could not doesn't matter, but they don't. They're only looking at the external output. What I say there is, using my resistance metaphor, you can kind of understand if there's tech debt there. If the AI can always do the change you request in the way you want, well, then I guess there's no tech debt there because the AI coder is not being resisted. If you looked at it, you might find tons and tons of internal problems, right? Like I'm not talking about the external effects that they might be causing, just the internal. You might find tons and tons, and I do find those. But if the AI always knows how to deal with it, and if the AI never has a problem, then I guess that's not tech debt. In my experience, that's not what happens. what I see happen is as these projects get bigger and bigger, the AI has a lot of problems with keeping it. It tends to like remove working things because there are no tests, making sure that they're staying working, or it doesn't it's we understand it's like a non-deterministic machine. I think we understand it is. Sometimes vibe coders don't totally like, why did it do that? I didn't say to do that. Well, it's a random box of nonsense. Like, so like we're just lucky that it does anything at all. But I see people talk about, and I actually do work with a lot of vibe coders. I do like a weekly 1 hour check in with a bunch of vibe coders, trying to give them some perspective on the code. So, and that's public, by the way. You could if you follow my LinkedIn, you could see me talk about that every once in a while. They are definitely having problems. Definitely, the kinds of things that they're having are the kinds of things we developers have with code that is hard, that is resisting us from changing. I find like the main thing they're running into is the lack of a design system. And so the AI is not building to a design system that is represented in the code. Like there's an abstraction of the design system in the code. And so you just see repeated CSS styles everywhere. It's just magic that it happens to look the same everywhere. But then as that gets bigger and bigger and bigger and outside the context windows, then it's not able to keep it straight. And it would not build that without you. If I were doing it, I would be prompting it to build the design system first, and then I would be building code on top of that. And I might have to show it how to do that by doing it the first couple myself, but then after it will definitely get the idea of it. And then I can make sure that it's not changing the design system code when it wants things that are maybe different. It's doing that by exceptions in the page code or something that makes sense, because I can look at the diffs. So I guess I would say to developers who are mostly your audience here, it's totally up to you how much tech debt is in the project. So, as it has always been. What's that?
Yeah, it's as it's always been. If you make small atomic commits and you're thinking through what you're doing and you're being intentional about your code, it's a tool. It's helping you be more productive.
Yeah.
And no negative impact.
And if it's giving you back so much time, the reason I use it is because it's giving me back so much time, invest a little bit of that time. Like, now that you have gotten your thing done a lot faster, take a little of that time and put it into like a useful refactoring or more unit tests, more edge cases. And the AI can help you do that too.
So what about with technical debt, where say you inherit a project that's 100,000 lines of code, it's a mess, it's a high level of technical debt. Have you tried it on that and had any good, bad results?
All the code bases I'm dealing with now are my own, so where I've done the bulk of it. And when I was at Atlassian, there was no good AI tools. I'm going to just say this because just from my experience with it, and I think everyone needs to try this. And also, I'm going to just say every month, if we're recording this, in the past, like even by now, it could be different. So it's really hard. Things change, but generally, I find code that's hard for me to change is hard for the AI to change. But it is sometimes good at explaining code, and even if it's just a second set of eyes, even if it's wrong, it could still maybe somehow give you some insight into that code. It's been really good for me. So I did recently add a feature to an open source project where it wasn't bad code, but I didn't know any of it at all. And I did start with the AI kind of helping me, explaining it to me and showing me things. It did end up not being very useful because it's a weird project that probably there aren't a lot of examples of. But I did run into a problem that it got me out of. And so I would say this whole thing, it's a new skill. If you just go into it and immediately reject it because it seems not to be good, I would say you should do more than that, because there are skills to learn. There are prompting and context skills to learn, and you also need to figure out where you are faster or where or the AI is good for you. But I do find the more unknown something is, either the language or the code base, I do actually find that the AI is very helpful at getting me oriented. But if the whole thing's a big mess, I don't know if the AI is just going to fix it for you. Like, I don't see that really happening. Maybe under your direction, but I actually find that normal refactoring tools are a little faster and better than than the AI because it tends to be slow. It's also could be expensive, and a lot of things that I'm doing, like extracting out a piece of it's cut and paste and a little bit of changing and global renaming, and the IDE has tools to doing those things. I tend not to reach for AI for refactoring because I'm pretty good with the tools that are already there. But for unit test generation, I definitely reach for it, especially if I already have some. It's good at using the pattern.
Okay, cool. I think my experience has been similar to yours. If it's something that I'm in charge of, that I'm thinking through and driving it work, you try kind of build this whole clone of X. It's a long way off doing that yet.
Yeah.
Okay, cool. So what's the best way of anyone getting in touch with you and buying the book?
So,
where can they find it?
Yeah, so I have a website, loufranco.com, L-O-U, Franco.com. You can find the links to the book there. It's on Amazon Kindle. The print book is coming out. It might be out by the time this podcast. It's being formatted right now, and or on LinkedIn, Lou Franco on LinkedIn. And just if you want to connect or message me, just tell me you heard me on this podcast. I'd be happy to answer any questions about that. Those are probably the two easiest ways to get in touch with me.
All right, awesome. Thank you very much, Ray.
Thank you.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. Feel free to check out these other videos on a similar topic.